Hello, guys. I'm going to talk to you about simplifying some radicals here, and this is going to help you whenever it asks you about perfect cubes in a minute. So this is just a reminder of some things. We're just going to do quite a few of these actually. You can zip through them if you know it, but don't forget what a square root is. A square root is asking you what times what will give me the 100, and we know that the square root of 100 is 10 because 10 times 10. Square root is an implied 2. You know there's a 2 even though it's not there, and 2 tens when multiplied gives you 100. So we call that a perfect square. Same thing with 64. The square root of 64 is 8 because if you take 8 times 8, you will get 64. It is also a perfect square. It's a perfect square when it works out nicely. Now, 8 is not a perfect square because you have to simplify it. The only thing that goes in there is 4. And we know this because you would make a perfect square list because you're making, because you have a square root. For a square root, use a square list. And the biggest number that goes into 8 is 4. And we would change that to 4 times 2, which is the same thing as square root of 4 times square root of 2, which is 2 square root of 2. So it's not a perfect square, but we could still simplify it. So what happens with you have a cube root? Well, when you have a cube root, you don't want a perfect square list. You instead want a perfect cube list. And you might not know these very well, so you might need to make a list to help you. 4 to the third is 64. 5 to the third is 125. I think, 6 to the third, I believe, is 216. Let me double check. Yep. 7 to the third, 343. And that's as high as I need to go because I know that 8 to the third is going to be too big. That's 512. So this is definitely not a perfect cube, but I can simplify it. So which one of these numbers on this perfect cube list can go into 500? Well, 125 goes into it 4 times. So that's 125 times 4. So that's the cube root of 125 times the cube root of 4. And the cube root of 125 is 5 because 5 times 5 is 125, and that would be the cube root of 4. So it's not a perfect cube, but it can be simplified, similar to how you do square roots, but with a perfect cube list instead. Cube root of 16, again, 1 cubed is 1, 2 cubed is 8, and that's the number I need to go into the 16. That's 8 times 2. Cube root of 8 is 2, and you are left with the cube root of 2. No, advanced algebra. Advanced algebra. That's the one they give first. They give the second one second. You have to do better on it, the second one. You get a lower score on advanced algebra, so she gives you that one first. Okay, sorry. Square root of 18. So now we're back to the square list instead of the cube list. So that's 1 squared is 1, 2 squared is 4. So make sure you're using the right list when you simplify. That will be 9 times 2, which is 3, square root of 2. Okay, I'm trying to get you to some variables here. I think we get the idea here. Yes, negatives are okay with cube roots because 3 negatives makes a negative still. So it does work. 3 to the third is 27. 4 to the third is 64. And if I take 108 divided by 2, that's 54. 108 divided by 8 maybe? 27. See, I wouldn't have found that. That's 27. So what we're going to do here is I'm going to change the negative 108 to negative 27 times 4. So it's not a perfect cube because it's going to have leftover. But when I take out the cube root of negative 27, that's actually negative 3. So it's negative 3 cube root of 4. So you can have negatives underneath a cube root. You can't have a negative under a square root because we know that's an imaginary number. But under a cube root, it is okay. All right, now we're going to talk about variables. So what's the deal with variables? Well, it's the same thing that's true with numbers. 10 times 10 is 100. So the square root of 100 is fine. Well, let's say it was a variable. Let's say it was k times k. That's k squared. So the square root of k squared is just k. How about the square root of k to the third? Well, there's no way I could make that happen. with just 2k. So what I would do is I would change it to k squared times k. The square root of k squared is k, so that would come out, and then I would have 1k left underneath. What about the square root of k to the fourth? Can that come out nicely? Yeah, because k squared times k squared is k to the fourth. The square root of k to the fourth is k squared. So with square roots, you're actually looking for even exponents because in essence, you're going to be like dividing them out. So when I have the 75k to the fifth, I'm going to look at the 75 separate than the k to the fifth. And there's two ways kids like to look at this. Some kids will say, okay, that's 25 times 3. We talked about that. Some kids will say, well, it's a square root, so I want to change the fifth to all these k squareds, k squared, and k. And you can do that. That's fine. The square root of 25 is 5, so I'm going to take this guy out. The square root of k squared is k. The square root of k squared is another k. And then what's left underneath is 3 and a k. So that's 5k squared, square root of 3k. But you don't have to do just k squareds as long as you know it can be even. So you can change the 75 to 25 times 3 and the k to the fifth to the k to the fourth times k. Square root of 25 is 5. The 3 will stay there, but what is the square root of k to the fourth? Well, we just talked about that. That's k squared, k squared. So this can come out with the k squared right away, and that will leave underneath it the 3k. Either way, oops, sorry, that's a square here. Either way, you'll get the right answer. You can look at it in pieces, or you can just make it an even. So let's try another one. How about 567n? Can the n come out? No. And I would need to find the biggest perfect square that goes into 567, which is kind of tricky. I'm typing some things in here. 81 goes in there. 567 is 81 times 7. And then you still have the n. So the square root of 81 comes out with a 9, but the 7n has to stay underneath because I cannot take the n out because it does not have an even exponent. How about this? Can the x to the fourth come out? Absolutely, it's even. 192, again, 81 will go, oh no, it won't, 96, 192, 64. 3 times 64 is 192, so that's 64 times 3. X to the fourth comes in, so the square root of 64 is 8. Square root of x to the fourth is x squared. It's like you divide the 4 by 2 on your way out almost. What's left underneath is a square root of 3. It's not a perfect square, but it can be simplified. Let's try a cube root now. So again, it's a cube root. So now I need a perfect cube list. 1 cubed is 1, 2 cubed is 8, 3 cubed, 27, 4 cubed, 6. Then we got 125. Okay, 64 goes into 320. Now, but what about a cube root of x to the fifth? So we're thinking about something that has to be there 3 times for it to come out because the cube root of x to the third is the only one that would work out nicely because that would be x times x times x. So in this case, I'm going to change the x to the fifth to x cubed x squared. Still x to the fifth, but this x cubed will be able to come out to just the x. So on these guys, you're looking for multiples of 3. That's a P, but we'll pretend it's an F. So we're going to change the 320 to 64 times 5, and we're going to change the x to the fifth to x cubed x squared. This allows us to take the cube root of 64, which is 4. You can't take the cube root of 5, but you can take the cube root of x to the third. That's just x. So those two came out, and what's left underneath is a 5 and an x squared. It's not a perfect cube because it has this left over, but it can be simplified. If it was a perfect cubed, it would be a multiple of 3. Let's try this one. Again, it's a perfect cube, so you need a perfect cube list. What goes into 162? 6 and 27. So that is going to be 27 times 6. Now, what about the x to the 8th? Well, there's two different things you could do. You could change the x to the 8th to x to the 3rd, x to the 3rd, x squared. And you could take the cube root of that. Or you could change it to the multiple of 3, which will be x to the 6th, x squared. Because the x to the 6th will come out, you'd kind of divide it out, and you're left with x squared, cube root of x squared. If you did it this way, you would take this x out and then this x, but they would have to be multiplied anyway, which gets you back to the x squared, and you still have an x squared underneath. So I'm going to change the x to the 8th to an x to the 6th, x squared. Cube root of 27 is 3. Can't take out the 6, but I can take out the x to the 6, because x squared, x squared, x squared equals x to the 6th. So that will be x squared, and then those guys will stay underneath, which is the 6x squared. Not a perfect cube, but it can be simplified. Let's try this one. Negative 1250. I know 5 to the 3rd is 125, and I know that's the one that's going to go in there. It is a negative, so I am going to change it to negative 125 times 10, because negatives are okay with cube roots. Now this b to the 8th, what am I going to change it to? I need it to be a multiple of 3. So 3, how about 6? Let's change it to b to the 6th, b squared. That would be b to the 8th, so it's the same thing, but this allows me to take out this piece, which will be negative 5, and this piece, which would be 6 divided by 3 is b squared, and then underneath would be the cube root of 10b squared. So that's how you simplify the cube root of that guy. Okay, again, it's not a perfect cube. None of these really are, but I hope that's enough to get you going on what a perfect cube is and what it's not, and how to simplify those radicals with variables.